Thank you for joining this talk. My name is Petros Zerfos. I'm a principal research scientist at IBM Research and the technical lead for the large-scale data engineering for the Large Language Models Initiative at IBM Research. Today I will be talking about the Data Prep Kit, our open source project that we developed and used to accelerate the development of large language models applications. So before we get into the models and the applications themselves of in AI, it's useful to remind everyone that every conversation in AI starts with models, but in reality it ends with data. That's also very well known under the concept and idea of when you give garbage into a system, and a model is such kind of a system, computing system, you garbage in, you get garbage out. And so, of course, no surprise that in a recent study by Gartner last year, 79% of participants that were interviewed by Gartner identified the data preparation and generation as the most common strategic tasks that were performed by the AI teams of the companies that were interviewed, which means that the teams themselves were not spending as much time on the models, but they were spending definitely a whole lot of time on preparing the data for these models. And furthermore, 30% of those participants, they view the data volume and complexity as one of the main challenges, the most challenging aspects of implementing applications in AI. So quality of data does affect the quality of the model. That's understood pretty much by everyone. And having this thing in mind, let's start discussing what we can do in order to help with preparing this data. Before getting into that, though, it might be worth revisiting the development life cycle of someone who develops a large language model application. Let us assume that a developer would like to make their large language model great in understanding filings from the Securities and Exchange Commission here in the US in the domain of finance. So the first question that they ask themselves, they typically get some sort of a pre-trained base model, and they ask themselves, okay, how well does my base model perform, let's say, in question and answering on these kind of documents, the SEC filings? If the performance is not satisfactory, then obviously the model needs to be improved, needs to be fine-tuned with SEC data or some other types of data. And then a whole kind of life cycle of acquiring new data, preparing them and assessing their quality, then using them for further model training and fine-tuning, assessing the model performance through some model validation and evaluation, and further assessment whether the fine-tuned model with the newly acquired and prepared data meets their needs. So, and this is an iterative process that essentially the developer goes over and over till they get into a model they can use for a large language model application that meets their needs. So in this kind of talk, we will be focusing on essentially providing the tooling for accelerating the part of preparing the data and assessing their quality, data quality. So for that purpose, we, as I mentioned at the very beginning, we developed and open sourced our data prep kit. It's available under the Apache 2.0 license, so it's freely available for use, experimentation, any type of use, including commercial. It's available at the link that is shown in this slide. And the data prep kit is essentially a framework as well as a collection of modules, a library, if you'd like, of transforms and annotations that can be used to for plugging in together into pipelines so that the developer of the large language model application, whether this is for the purposes of fine-tuning, instruct tuning, retrieval, augmented generation, or something else, can use in order to put together pipelines that take essentially data, they extract it from PDFs and HTMLs and whatever other source document formats, and through several steps of annotation and quality assessment and cleansing, this data is eventually converted into tokens that go into fine-tuning or RAG purposes. We designed the model, the data prep kit, to be to scale from from laptop all the way to a complete data center, supporting a number of big data platforms such as Ray, Spark, as well as just pure Python. It is open source, so we very much welcome contributions from the community. As a matter of fact, the community has already started contributing transforms and functionality outside the original one that we had developed. And to conclude this kind of whirlwind presentation in this slide of Data Prep Kit, it is actually battle hardened. We actually did use it to prepare the data that went into the pre-training of IBM's Granite series of models that are available on Hugging Face, also under Apache 2.0 license, the models themselves. And we have used it to process hundreds of terabytes of text. So it has run essentially at very large scale as well. What does the Data Prep Kit include? First of all, it covers large language models that target both a natural language as well as code. So essentially under a unified framework, we support both language and code. And for that purpose, we have a number of modules that fall into various classes. Modules that range from data ingestion all the way to deduplication and various kind of filters for assessing the quality, either linguistic quality in the case of language models, or code quality in the case of large language models for code, foundation models for code. And these essentially modules are supported under a number of runtimes. They can run just purely on Python, driven, for example, by a Jupyter notebook, and such kind of examples are included in the Data Prep Kit. Or they can run in a scale-out fashion on Ray and Spark. And moreover, these can actually run completely packaged into Docker containers. So they are cloud native, these modules. So they can be readily deployed onto Kubernetes clusters, where essentially they can cover and be scaled out onto a full kind of data center. But what do these modules do, right, in the Data Prep Kit? So these modules essentially are used to annotate and transform unstructured data at their very core. So the goal is to curate the data sets for training and tuning. And generally, the data sets, once they're ingested, they undergo under a series of transforms or annotations. The transforms modify the actual content of the document that has been ingested. The annotations essentially add some sort of a characteristic, some score, for example, that might denote quality of a given document. That could be linguistic quality, that could be a note on whether offensive language is found in the document, some personally identifiable information, or something else. So as the documents undergo a series of such kind of transforms into essentially a pipeline, at the very end, typically, these annotations can be used further by filters, and this is also another type of module in the Data Prep Kit, to select documents to either keep or drop based on the various annotations. And then after that process is done, then tokenization takes place. Tokenization is another module in the Data Prep Kit, where essentially the tokens are prepared to be used either for pre-training or for fine-tuning purposes. The Data Prep Kit includes actually, as I mentioned, a framework through which users can very easily extend and contribute new modules without having to worry about scale-out purposes or hardening it for big data platforms, or all sorts of other things that are needed in order to essentially make use of these kind of pipelines in production. These are all handled by the Data Prep Kit itself. The internal representation of the documents and the data essentially that is ingested follows a CSV-like form in the very well-known pi-arrow table format. You can think of it as essentially columns that can include from the URL source, for example, of the document to the actual document contents, unique document identifiers, as well as all sorts of annotators annotations that are added by the various annotation modules of the data prep kit. For example, the language in which the document has been written, English, French, Japanese, or anything else. Some annotations that denote document quality, for example, perplexity. And in general, the transforms themselves can be applied in any order. The data prep kit does not prescribe the order in which those can or should be applied, and it's left up to the application developer of the large language model application. As I mentioned before, based on the various annotations, as shown in this slide, filters can be applied in order to essentially keep or drop documents from the document collection based on the desirable characteristics that we would like our data sets and our corpus that we will use either for pre-training or fine-tuning to possess. For example, documents written only in the English language, where they have perplexity score above a certain threshold. We used this essentially approach, as I mentioned, to prepare the data that went into the pre-training of IBM's Granite large language model series at various parameter scales, and has run like basically on billions of such kind of documents, all stored in parallel tables in the Parquet file format. I invite everyone, of course, to visit and explore the contents of the data prep kit in GitHub, the open source project. There's, as I mentioned, more than 20 transforms and annotators that we developed for the purpose of processing data for both code and language models. One exemplary such kind of annotation and module, for example, is the text extraction from PDFs. This is a very common type of operation. Lots of documents are found in PDF, in the very popular PDF format. We have used another open source library as the core text extraction engine, where we essentially extract the text and convert the documents from their original PDF format either to structural markdown or JSON formats. The library is called DocLink. This library is also open source at the URL that you see in this page, and it converts, as I mentioned, any PDF document to JSON or Markdown. It understands the very detailed page layout with all the sections, subsections. It's able to follow the reading order, for example, in the case where you might have multiple columns in your document, as well as recover the actual table structure. So it understands and puts correct markdown around tables in order to be learned by an LLM. It extracts the various metadata from documents, such as the title, authors, references, and what have you. And finally, it can optionally apply optical character recognition, OCR, in case the PDF has been produced through scanning. It's essentially a scanned PDF. It's a very high-performing library. It's essentially encapsulated into a transform in the data prep kit that can be used to essentially perform this text extraction at very large scale. I've mentioned a few times the scale of the data prep kit that is able to operate at is what we call from laptop to cluster scale. You can simply download and start using it almost immediately on your laptop, just through Jupyter notebooks on very few documents. You can run it in a multi-core fashion on a powerful server, or you can actually deploy it on a complete kind of data center, hundreds of nodes with thousands of CPU cores, as we have done internally for our needs, right, for preparing the data for pre-training. We provide Ray and Spark wrappers that can scale out the actual transform, the modules, without any code changes, so long as the transform is embarrassingly parallel. This is actually the case, turns out to be the case for pretty much all of the modules that process unstructured data. So you essentially only write once your either transform code or your annotation code, and then the scale out happens completely transparently. A number of environments are supported, runtime environments to run the data prep kit, including Docker and Podman desktop container engines, Kubernetes clusters through the kind system, as well as I/O for these documents, either code repos or, as I mentioned, text documents in a variety of formats. The I/O can happen either from the local file system or through Cloud Object Storage and S3 APIs, where you can essentially have pretty much infinite capacity. As already alluded to, it's production-ready use, the data prep kit. We have processed in excess of 12 petabytes worth of data. We have included checkpointing, metadata kind of logging in terms of the jobs that are run through the data prep kit, as well as auditing functions. And all of these are actually transparent to the transformer of the module. So essentially the application, LLM application developer, focuses only on the actual functionality of annotation or transform, and all the rest, which are needed for production essentially and scaled out use, are provided by the data prep kit itself. Low-code orchestration of pipelines, essentially chaining various transforms and annotations and filters, is provided via either Kubeflow pipelines, in the case where the pipeline is deployed into the data center scale, or can be done, of course, through Jupyter notebooks, in the case where very few documents, few dozens, run essentially and get processed on our laptops. Finally, the project itself includes various quick start guides that can help the user kickstart document preparation effort, data preparation effort, with very minimal effort. In summary, as we started at the very beginning of the talk, high quality models require high quality data. Otherwise, garbage in, garbage out. So for this reason, we developed the data prep kit, and we use it very extensively in production to prepare the data, which is a very challenging and time consuming, as we noticed early on, task for most AI teams, whether they develop RAG applications, fine-tuning applications, or instruct tuning. Different downstream applications necessitate different data processing pipelines. Therefore, the data prep kit does not try to be prescriptive in terms of what needs to be run in which order, but provides the flexibility to the end user, the one that prepares the data, to put together pipelines that fit their needs. The challenges are amplified, of course, with the various modalities involved in preparing data for LLM applications, from the various kind of complicated structures of PDF documents to mixing language and code and what have you. So these essentially tasks are handled by the data prep kit to a large degree, and as well as, very importantly, the scale that at which an application developer would like to process and prepare data, from a few dozens of documents all the way to billions of documents. Data Prep Kit is an open source community project, Apache 2.0 license, so extremely permissive for all your data preparation needs. And of course, your contributions are welcome. At the URL shown in this slide, you can find all the gory details, and you're very welcome to download, experiment, and use and contribute to it. Thank you very much for your attention and for joining this session.